Okay, here we go. So we're dealing with compound inequalities today. Compound inequalities are two distinct inequalities joined by and or. In other words, we have, rather than just one inequality, we have two of them. We have two conditions that our variables are trying to meet. It either needs to be true for both things, which is an and, or one or the other, which is an or. Okay? So we're either going to be joined by an and or an or. There's actually a couple of versions of the and situation. Okay. The graphs of an and overlap the two inequalities. Okay. And when you have to look at them, you have to look, okay, I want something that meets both conditions. So there are two ways, and I'm going to do an example here of ands and graphing them. Or, yeah. And or. I know. So in the and, you have two possibilities. You could either have something like x is greater than 2 and x is less than 5. That means whatever number I have has to be greater than 2 and less than 5. And it has to meet both of those conditions. So if I were to graph it, I would say, okay, here's a 2, 3, 4. Here's my 5. Do I have an open circle on the 2? Open circle on the 5. And I want everything larger than 2 and smaller than 5. It has to be true for both of them. So that's the compound inequality that's between those two numbers. Now I said there's two ways to write an and inequality. This is one of them where you have two separate ones separated by an and. The way you're going to see it more often is those two put together. And it's actually very easy to get from the graph. What are the two numbers I'm dealing with here? 2 and 5. So I have 2 and I have 5. Where is my x? On the graph, it's between them. My x is between 2 and 5. Now my inequalities always point the small end, when I act like this, always towards the smaller numbers. And they're not or equal to, so I have x is between the 2. X is larger than 2, but smaller than 5. That's also an and. This, and this mean the same thing. They mean the same thing. Okay, both of them mean the same thing. Two ways to write the same thing. Honestly, you're going to see this one more often. You're going to see the second one more often than you are the first one. Okay, then we have the or situation. Okay. And we have an or graph. The solutions are of each of the two inequalities. So it's not where both of them are true, it's where either one of them happen. And your or graphs are almost never, they're never combined into one. So when you have an or graph, for example, you would have something like x is less than -2, or x is greater than or equal to 1. Guys, knock it off. Okay. One of those two situations. It's or. So when I go to graph this, okay, x is less than -2. Can something be less than -2 and bigger than 1 at the same time? No, it can't happen at the same time. So we have an or. It's not something that cannot meet both conditions. It's going to be one or the other one. So if I graph the first one, x is less than -2. Okay, I'll put -2 here just because. And I have an open dot. And I want everything less than that. When x is greater than or equal to 1, so there's -2, 1, 0. Here's where 1 is. And I have a dot and everything larger. When you have an and situation on your graph, it goes towards the center. It's the overlapping. When you have an or, they go outside. Okay? They don't overlap. It's one or the other. It's either less than -2 or it's larger than 1. It's not both at the same time. It's one or the other. If you have an or and you end up with both arrows pointing in the same direction, you screwed up somewhere. Probably forgot to flip an inequality when you divided by a negative or something like that. So if you have an or and they're both pointing in the same direction, you made a mistake on one of them. Okay? You made a mistake on one of them because they do need to be pointing in opposite directions if you have an or. They're both pointing in the same direction, you forgot to flip something. Okay? So it's a good way of checking your work while you're doing it. Okay. Next part, interval notation. You're welcome. My pre-calc kids were confused enough by it. I'm not making you guys do it. Okay. In interval notation, it's just a different way of writing an inequality kind of solution. That's all. You know, it's a different way of writing these kinds of things. That's all. But I'm not going to make you do it. We're not going to worry about it. Okay. Okay. Next two examples, next two problems, writing a compound inequality. Okay. So the first one, all real numbers that are greater than -2 and less than 6. This one I have an and situation. I mean, it tells me right here, and. So I have two inequalities I'm dealing with. The first inequality, all real numbers that are greater than -2. X is greater than -2. And what's the little word that I underlined? And. And the other inequality, X is less than 6. Thank you. Okay, so -2, 1, 2, let's see, 1, 0, 1, 2, 3, 4, 5, 6. On -2, I've got an open circle. On 6, I've got an open circle, and I've got everything in between. Okay, that's an and. Okay, the next one, what do I have? I have an or. If you look, ooh, there's my very important word right there. I have an or. So I do my first inequality. All real numbers less than 0. 2. Sorry, I underlined the wrong or. That's the or I'm dealing with. That's a different or. My bad. So numbers that are less than 0. So X is less than 0. Or greater than or equal to 5. So greater than or equal to 5. Pretty easy, right? So that's not too bad. Okay. So I have 0, and I want all the numbers less than that. 2, 3, 4, 5, and all the numbers greater than or equal to that. So I have a solid dot on that one. Does that make sense so far? And means both things to be true. This and that. Both conditions need to be met. Or means one or the other. It's either true this one or this one. Either one's okay. I don't need to beat both. But and means I need to have both. Okay. And you have the overlap. It's between the two numbers, or it's on the outside of the two numbers. Okay, so let's start solving some. Okay, this first problem is a compound inequality, and it is an and. Okay, so I need to solve this. Now, you can break this into two problems and solve each problem individually. If I had you doing number 9 on your homework, that's the only way to do number 9 on your classwork. I'm not making you do it because I don't want to worry about that. Here's what I like to do when I see this kind of a compound inequality. It's an and. It's actually very, very easy to do. But instead of doing everything twice, you're doing everything 3 times. So I want to get m by itself. I have m minus 4. What do I want to do to get rid of the minus 4? I want to add 4. So I add 4. However, I have 2 inequalities. So where do I add the 4? I add it here. I also add it here. And I add it there. I add it to all 3 places. Anything that's separated by an inequality, I add it to each side of that inequality. I have 2 inequalities. I have to do the first one, the middle one, the outside one. Okay. So negative 3 plus 4 is 1, is less than or equal to m, which is less than 3. And then I do have to graph this, but that's easy. I have a 1, I have a 3. On the 1, what kind of a dot do I have? I have a closed dot. On the 3, what kind of a dot do I have? I have an open dot. And everywhere in between. Now the next one is where we have fun. Any questions on this before I move on? Okay. Problem number 3, writing and solving a compound inequality. So you have to come up with the equation as well as the answer. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86. Okay, less than 84 would be a B minus, more than 86 would be a B plus. You want a B, you need to be between those 2. You scored 86, 85, and 80 on the first 3 tests. What possible scores can you have to earn on the 4th and final test to earn a B? So what I want to know is I want to have an average score between 84 and 86. Okay. How do you find an average? What do you do to find the average of numbers? Divided by what? The number of things you have. So I currently have an 86, and an 85, and an 80, and I want to know what I'm going to get on the next test. Now, how many of those do I have? 4. So to find my average score, I take that, divide it by 4. Okay, does that make sense? Now, what does it have to be more than? What's the minimum score I could have? I could have an 84. That's my minimum here that I want to have to do it. Okay? And this is an important word right here, inclusive. If you see the word inclusive, that means it's or equal to. So that means this has to be greater than or equal to 84. And what's the other end I'm looking for? 86. So it has to be less than or equal to 86. Okay. Now, the first thing I want to do to actually make this an easier problem to do, 86 plus 85 plus 80, add them all together. And what do you get? 251, thank you. That's what I thought it was. I couldn't remember. So I'm just going to, because I have an eraser to easily erase this. So I have 251 plus x over 4 is less than or equal to 86. Now, you have a homework problem, or I should say a classwork problem that looks just like this. My first step is not subtracting 251 from both sides, because I have 251 plus x. All of that is being divided by 4. So my first step is to actually multiply times 4. I want to multiply this times 4, and this times 4, and this times 4. Somebody please tell me what 84 times 4 is. 336. Less than or equal to, and here, this 4 and this 4 cancel, so I get 251 plus x, which is less than, what's 86 times 4? 344. Now what's my next step? Subtract 251. Minus 251, minus 251, minus 251. I have to do it in all 3 places. 336 minus 251 is 85, thank you. Let's try to remember from earlier today. And then 344 minus 251, I think that's 93. So if you want to be in the class on the next test, you need to get somewhere between 85 and 93. Well, in this particular situation. Questions? Okay, so we've done a couple of compound inequalities. Both of the ones we did were ands. Numbers in between, numbers in between. This one is an or. Okay. And I think in many ways an or is easier to solve. Because what do? You solve one side, and then you solve the other side. You just solve the 2 equations. So, I want to do this. What's my first step on the first equation over here? Subtract 2 from both sides. 3x is less than or is less than negative 9, and now I do what? Divide by 3. X is less than negative 3. So there's one part of my answer. It's not all of my answer, that's only half, because I have the or. So it's this or what I get from solving the other one. Now I solve this one here. What's my first step? Subtract 5. Negative 4x is less than 1 minus 5. Negative 4. Divide both sides by negative 4. Be careful. I get x and I get 1. And what else do I need to do? Flip the inequality. So x is less than negative 3 or x is greater than 1. So less than negative 3, negative 3. Everything less than that. Or greater than 1. Okay, less than 3 or greater than 1. Questions?